Hey everyone, Vessel here again, ready to conclude our summarizing and comparing distributions here. So this is part 3 of this series, and wanted to go through this one. I think this might be the quickest of the bunch here. So let's dive into part 3. This one is really just about reading a display that you might be kind of a weird display. So basically starts out with this prompt here. There's a lot of text in this one, but 2 pain relievers, A and B, are being compared for relief of post-surgical pain. 20 different strengths in milligrams of each drug were tested. 800 post-surgical patients were randomly divided into 40 different groups. 20 groups were given drug A. Each group was given a different strength. Similarly, the other 20 groups were given different strengths of drug B. Strengths used ranged from 210 to 400 milligrams. 30 minutes after receiving the drug, each patient was asked to describe his or her pain relief on a scale of 0 to 100, where 100 means it's totally gone. The strength of the drug given in milligrams and the average pain rating for each group are shown in the scatter plot below. Drug A is indicated with A's, drug B with B's. So again, there's a lot of information in this particular prompt. Some things that I notice students overlook a lot is the drug range. So it went from 210 to 400, and they really go into this design of the experiment quite a bit up here. So that's not been a massive aspect of our course at all yet. So that's coming actually, and we'll talk about the type of experiment that was designed here. But we got this display. You can see down here we got our strengths in milligrams. We've got our pain relief on the side here, and one thing that kind of stands out looks like B's kind of hovering, like B's almost non-effective at all until later on, after what is this going to be 280 or 290, 280, so about 280 milligrams we start to see some relief for B, and then it looks like it's steadily increasing fairly linearly, where it eventually passes drug A, it looks like. So drug A, on the other hand, pretty consistent, fairly flat. A little these lower dosages might have a little more variability, and maybe there's a weird one here too, but for the most part, fairly consistent throughout the whole process. So anyway, let's see what these questions are asking and try to answer these in a high quality way here. So based on the scatter plot, the first thing I want to be super careful, it says based on the scatter plot. So we're going to use the scatter plot, and I know that everyone, I guess, to get some practice with reading these very, very literally, it says based on the scatter plot, describe the effect of drug A and how it's related to strength in milligrams. So sometimes that people will say something on this response that doesn't relate to strength in milligrams. So it's really important to read carefully, and even the word "and" is underlined here. So I think what has to happen to get full credit for this kind of response, we can't just say stuff like A basically stays the same. Like we have to be more specific in that. We want to be able to look at this answer and know what happened to drug A without even having this picture in front of us. So that's what we're going to try to do here. So based on this scatter plot, I want to be more specific. It looks like, I'm going to look at that in a minute. I'm going to say that's a little over 50, maybe about 75. So I don't have the specific numbers on this thing, but I'm just sort of highlighting where I think the A's kind of fall. So I'm going to write about that. So based on the scatter plot, the effect of drug A is between 50 and 75 on the pain scale relief, or pain relief scale, for all dosages from 210 to 400 milligrams. Now, something that I've noticed in the past, a lot of times students don't realize that the graph goes from 210 to 400. Now, I mentioned it here, so I don't want to use 200. Sometimes students say 200 to 400. I see that a lot, actually. So I technically don't know what would happen at 200. If I had to predict, I would probably predict it would also follow that same pattern, but that's not going to be our job here. We don't know what happens at 200. Maybe 200 is something totally different. We're not going to make that type of comment. So I have to say from 200 to 400, so 210 to 400, so that that's all I know about here. Based on the scatter plot, describe the effect of drug B and how it's related in strength in milligrams. So I think this one is a little more complicated. We actually have to maybe break this up in a couple of pieces. The effect of drug B is really close to 0 for dosages from 210 to, let's double check that, 10, 20, 30, 40, 50, 60, 70, 270 milligrams. And then from dosages of 280 milligrams to 400 milligrams, there is a fairly constant increase in pain relief. Fairly constant increase in pain relief. So I think describing B is maybe a little trickier. A lot of times students will leave off that first part in general. They might just say, like, as you get higher milligrams, then the dose or the pain relief increases. And that's actually true, but only true from about 280 on. It's not really true those first 60 milligrams or 70 milligrams there. So anyway, I want to make sure we break that down into two pieces. Just saying that it's constantly increasing is going to get partial credit for that one. So it's kind of a two-sentence piece for that one. And again, one thing that's very, very important, it says how is it related in milligrams. So a lot of times students don't list or write about these very specific dosages. So that's an important piece to this too. So again, here's what you should have in your head. If somebody reads this, they could recreate this graph. So hopefully this is a way that you can, if you read this sentence, you would get this image in your head. So if you read your response and you can't, or have someone else read it as a test, have a parent or guardian or brother or sister, somebody else read it, if they can make this display, it's kind of a fun game actually, then you've probably done a pretty good job. If they can't, then you need to get back to the drawing board there. So I think that's a good way to think about all of these tasks actually. Like when you're describing something, think about it if they didn't have the picture. How could they recreate it? And then finally this last part, I'm going to switch colors since I went over here. Which drug would you give and at what strength if the goal is to get pain relief of at least 50 at the lowest possible strength? Justify your answer based on the scatter plots. Again, we're using the scatter plot. So I don't know, this one seems pretty obvious, but I don't know if not everyone gets it correct. So it's not always obvious. It says a pain relief of at least 50. I actually kind of draw this line in here at the least possible dosage. So one thing I notice, it looks like we meet it right here at a very low dosage. This is 210. So I guess what I would say, and there's only one answer for this, you have to choose drug A at 210 milligrams. That is going to give you the 50. It's pretty safe it's going to give you 50. And it's also the lowest dosage. If you gave B at 210, you're going to get almost no pain relief. Now if the goal was different, if the goal was getting as much pain relief as possible, I think that would change our answer here. We would say, well, let's just give B at 400 milligrams. That would probably help the most. That seems to be the case from the display. B does work great at 400, better than A. But if the goal is least dosage and getting at least 50 pain relief, we're going to go with drug A here. So the answer based on drug A at 210 milligrams will likely get a pain relief of at least 50. So I got to be able to say, like, well, that's true, but I might want to which drug and which way it says to justify it too. So I got to make sure that I say at 210, drug B offers little to no pain relief. Sorry. Little to no pain relief at 210. So that's which drug I would give and at which strength. And it's not enough to just say, oh, well, A at 210. We got to say why that 210 is better than B. So using the smallest dosage, A is going to do the trick here. So that's it for this question. Again, this one's sort of sneaky difficult sometimes. It seems a little more easy than it is, but wanted to go over that one with you as well. And thanks for checking this one out. Hopefully this is helpful information for you, and I'll talk to you soon.